Then we will go over to the next presenter, Niklas Begley, using Rust with Elixir for code reuse and performance. Welcome, Niklas. I know it's late where
Thanks
you
for
are.
having me.
Yes, I hope you. I hope your laptop will survive.
I hope so too. Yeah, and the power of caffeine compels me.
Yeah, exactly. So let's kick it off. And again, welcome to the Func Prog Sweden.
Yeah, thanks very much. Yeah, so I'm here today to talk about using Rust and Elixir, and how we use those two languages for both code reuse and performance. And this is going to be kind of a story style talk. So I'm going to walk through the scenario that I found myself in as I was building Doctave, and I had these technical problems that I had to solve. And kind of unexpectedly, I ended up finding that the best way to solve this problem, or this set of problems, was actually by combining these two languages in a way I hadn't done before. And I'm hoping you're going to find it interesting as well. So a little bit more about myself. So my name is Nick, and I'm a founder of a company called Doctave. I'm a software engineer by training, based in Helsinki, but currently on the road. And yeah, I worked mostly in kind of early stage startups during my career. Right now, I am working on a new company called Doctave, and this is a Docs as code solution. So for all your developer documentation needs, the idea is that you can store your Markdown documentation in Git, and you push your changes to your documentation to us as part of CI/CD, and you get this nice place where you can read and search all your docs in one place, but still get all the benefits and the developer ergonomics of using docs as code. So you can do documentation reviews and pull requests and so on and so forth, and use your favorite editor to edit Markdown. Yeah, we're founded in 2021, and we're currently in open beta. But yeah, so I'm going to talk into a little bit of background about how I came about, how these problems that I had to solve came about, and then how I went about solving them. So Doctave comes in two parts. So the first part was actually, it started its life as an open source project, and still is an open source project today. It's a static site generator, which is built in Rust. It's open source, free to use, and it takes your Markdown files and it will build a very nice, easy to use the developer documentation site from them. And you can deploy those sites on your favorite static site host of choice, whether it's GitHub Pages or something else. And then we have also Doctave.com, which is the paid service that we provide. It's built in Elixir, and more specifically the Phoenix stack. And you can think of it as a specialized hosting platform for Doctave documentation sites. The idea being that if you just have one project that you want to document, the open source solution is fine. But if you have n different projects, you might want to have them all under one roof. And yeah, so the Rust CLI came out about a year ago, and I chose Rust for it, partly for speed, but I think actually more importantly than that, I wanted this CLI to be as easy as possible to distribute. I previously worked at a company that had a developer toolchain that was built in Ruby, and that was just a nightmare to get working on developers' laptops, especially if they weren't Ruby developers and didn't have a proper environment set up. So the power of Rust and also languages like Go and Zig and so on and so forth, is that you can compile them down to these nice static binaries that you can just drop in your path, and they work, out of the box, very, very easy to use. So that was the main reason for using Rust. Also, I'm a big fan of the language in general. But of course, Rust is probably not the best solution if you want to build a web application. Some people are doing that, but they're very brave people, kind of at the cutting edge of technology. So instead, I chose the Elixir and Phoenix for the web platform for us. And the Phoenix stack I found is incredibly you can be incredibly productive in it. And as a web framework, you get these features that basically no other web framework gives you out of the box. Like, I'm not going to go into them in detail now, but I encourage you to go and look at the feature set, and things like live view and built-in distributed pub sub and presence systems, and of course Elixir being built on the Erlang platform, you also get all the benefits of OTP and Beam built in. I'm going to talk about that in a moment as well. So one of the goals here, of course, was that the HTML that we generate, had to be identical, both when we were using CLI and Doctave.com. I didn't want them to be different. But of course, now these two things are built in two different languages, so this presents itself with a problem. Like, how are we going to actually make sure that we achieve this goal? And because this is kind of a key feature of Doctave, we need to do this very well. So on the Rust side, what we were doing, we pulled in a library called pulldown-cmark, which is a fantastic library for dealing with Markdown. It adheres to the common mark spec. It's very fast, and it's also very versatile. You can actually do some very cool customizations with it, where you can augment the AST as you're parsing it. Very, very powerful. And on the Elixir side, then when the time came to actually start building the Elixir side, I pulled in the main Elixir Markdown processor, which is called Earmark, made by the famous Dave Thomas, and I put this in and I sort of called it a day. But of course, there's a few problems here. So one of them is that Markdown, when I say Markdown, usually people understand what we're talking about, but it turns out that Markdown is not very well standardized. There are a few quote unquote competing standards of Markdown, and there's not necessarily any guarantees that two different Markdown libraries are going to produce the same output for a given input. There might be different features that they support, or they just might be subtle differences that creep in. And also, like I mentioned, we were, the Rust to Markdown parser, gives us the ability to customize the output, and we're actually using that for a few things in Doctave. So you can, for example, Merbe.js diagrams. You can embed charts into your Markdown files. Also things like callouts, where you can kind of highlight a piece of text or piece of content if you want to bring attention to it on the screen. And like, kind of smaller things like being able to use emoji shortcodes, kind of like on GitHub, and get those rendered out, in the browser. These are problems that, they weren't immediately at least solved, by using these two libraries. But, I was at this point, I was, busy building Doctave.com, and I had a million other things on my to-do list and of things I had to build. So I decided I'd deal with that later. So fast forward a few weeks, and I realized that actually some of the requests on that we were doing were taking a suspiciously long amount of time, and I kind of started digging in on Doctave.com, and I started digging into what was going on, and I realized that actually Elixir was spending a non-trivial amount of time parsing Markdown. So if you usually kind of the way we think about this is that web request budget, tends to be about 100 and 200 milliseconds, depending on, depending on who you ask. But that's kind of that's the budget that you have if you want to have an application that feels snappy, so to speak. So as you can see, so in this chart, you can see that this has inputs of between 2.5 to about 160 kilobytes. And what you can see is that, as we start having bigger and bigger inputs into the Markdown inputs into the Elixir Markdown processor, we actually start taking like on the order of hundreds of milliseconds fairly quickly. And if we want to actually have a performant website, we can't really be spending 400 milliseconds just parsing this Markdown. This seems very, very wasteful, and we wanted to do better. So of course, what's the solution that any self-respecting software engineer would do to solve this? We build a cache, of course. And this is where, Elixir and the Erlang ecosystem, of course, shine. I'm going to walk you through like how we actually ended up solving this first. So since this is a functional programming meetup, I'm going to assume that most people are fairly familiar with Erlang, but I'm just going to give a whirlwind tour of the basics. So Erlang, of course, is famous for its actor model, and the idea of having massive concurrency, being able to schedule these lightweight processes, up in the millions if need be, with very small memory footprint, and they can be kind of terminated and created at will. And your program ends up looking like a tree of these processes, like these the processes are further up in the tree, supervising the ones at the bottom, making sure that if they fail, they get restarted, or and so on and so forth. And this is kind of where Erlang gets its fault tolerance and resilience. Well, that's why it's famous for it. But But another thing that's also built into Erlang is something called ETS, or Erlang term storage, which is the simple way of saying it is that it's an in-memory key value store, or you could even call it a database because it has some fairly interesting query functionality as well. But yeah, you can actually, you don't have to pull Redis or Memcached or something like this into your stack if you're using a system, on the Erlang running on the Beam. You actually already have these capabilities built into the language. So the solution that we ended up building here was that kind of looks like this. So the idea is that if a web request would come in, we would hit a renderer, which would then talk to a process registry, which supervises a whole bunch of processes that are responsible for a given project's Markdown and HTML. So the renderer would ask, hey, can you give me the ID of the process that owns this particular piece of content? The process registry will respond and say, hey, you need to go talk to this guy. The renderer then goes, hey, can you please give me the rendered HTML for this given input? And the project process now, if this is the first time it's being asked this question, it's going to generate the HTML, by calling Earmark, and cache that HTML in ETS, and then send back the response. And if this is the second time, or that it's seeing that, it's just going to go straight to ETS and return the HTML. And this is a fairly like simple but functional cache. And a really cool thing also about Elixir and Erlang in general is that what you can do is you can tie the lifetimes of these project processes to the ETS table entries. So what you can do is that these project processes, you can say that, hey, I want you to terminate yourself if you don't actually get any traffic within 5 minutes. And then when you terminate yourself, when you do that, clear the ETS entries that you're responsible for. So this is where, so you can actually get this kind of dynamic clearing of the cache, for, cold projects that are not being accessed at any given time. Now this is what we actually went with for a little while, and it worked decently. But of course, is there a better way? The problem with caching is that you solve one problem, but you introduce like 16 other ones. What happens if you have a ton of traffic that comes in? You could start running into memory pressure, and caching is just a difficult problem overall. And while we did solve the performance problem here, we did not solve the standardization or the feature parity problem that I mentioned earlier. So we still have that to attend to. So I started looking around for a different way to solve this completely. And that's when I came across a fantastic project called Rustler. So Rustler is a library for writing Erlang NIFs in Rust. So Erlang NIFs stand for native implemented functions. And the idea is that you can include some native code as part of your runtime in your application. And then your Elixir code can invoke those native functions as if they were Elixir functions. So of course, some functions in the Beam or in the Erlang VM are already written, in C, and they're compiled into native code, and you can invoke those. But in a similar way, Rustler allows you to inject your own library code into the runtime. And Rust is actually a really good choice, arguably, for writing NIFs. NIFs are sort of dangerous in the Erlang world, because if your NIF crashes at any given point, it's actually going to bring down the whole Beam process. It's not going. It's all the fault tolerance guarantees that Erlang has just go straight out the door. The whole operating system process will come crashing down. So you need to be sure that your NIFs don't crash. And this is why Rust's compile time guarantees, where they come in and where they really shine. Rust, it's a low-level language, but the compiler and the type system provide these memory safety guarantees and concurrency guarantees also, that really kind of completely eliminate a set of bugs, assuming you're using safe Rust. And you can sort of just kind of rest assured that, at least compared to writing a NIF in C, this is going to be a lot safer. So yeah, so I looked into this, and this seemed like a really, really good option. So, what would it take to actually put this in? Well, the first thing I did was actually I took the Markdown rendering portion of the CLI that we had in Rust, and I extracted it into a Rust crate. So it's actually, you can actually go and see it on GitHub as well if you like, and it encapsulates the logic for parsing a Markdown document into HTML. And essentially, it exposes like a single function called parse, and you can pass into it a string and an optional like a configuration struct that will set certain parameters on it. And I'm actually going to show some screenshots of some code now, so just to show how easy it was then to pull this in. So what Rustler will do is Rustler will create a tiny little embedded Rust project inside your Elixir project. And in there, what you have to do is write the glue code that maps the Rust data structures to the Elixir data structures. Excuse me. So what you see here is that parse function. At the top on line 16, you can see this is a Rust macro. That's basically just saying, hey, Rustler, expose this parse function for me. And all the function is doing is taking those arguments from the Elixir side, converting them into the Rust specific ones, and then on line 37 we're just calling that Doctave Markdown parse function with the given input and the options, and returning a data structure that Elixir can understand. And that is that there's another maybe 50 lines or 30 lines that I've omitted here just for brevity. But like the whole glue code is less than 100 lines in this case. On the Elixir side, this is the whole parser module where the Elixir parse function here will then on runtime get replaced by Rustler with the function that I just showed on the other side. And this actually turned out brilliantly. So what we ended up doing was we went from this, which is not super complicated, but it's not trivial either, to this. Now the renderer just calls the Doctave Markdown library, and it gets some HTML back, and it's a lot faster. So with Rust, it turns out that we rarely spend more than a single-digit millisecond rendering Markdown, and which is not very surprising. Like Elixir is a very fast language when it comes to like kind of massive concurrency and like an IO, but for CPU bound tasks, it's never going to be able to compete with something like Rust, which compiles down to native code. So I thought this was a huge win, because essentially, this caching, with this caching solution, we were trying to kind of solve this problem of it's taking too long, but we still hadn't, solved those other problems of, code reuse and having to re-implement things twice, and maybe having issues with the output not being the same. But I felt that like this Rustler solution really just made the problem go away completely. Now suddenly we can use the same code in the same place, like in two different places, and we also made things a lot faster and a lot simpler. The integration that Rustler lets you do was extremely straightforward. It was an afternoon of work, and this was just a great win. And now we're 100 times, and we're also 100 times faster, and things are simpler. So what can we actually learn from this? Like I just said, cross-language integration, in this case especially, was delightfully simple. And it can sound scary sometimes, how are we going to make these two languages integrate with each other? Is it going to be really complicated? But at least in this particular case, and I can't comment on other language combinations as much, but this actually I felt like was a huge win. And I think a big shout out has to go to the Rustler maintainers, who really made this whole process incredibly easy. Of course, there are some caveats here. So, this will mean that, when you're developing the Elixir code, you're also going to have the Rust toolchain installed. This is going to have implications for CI/CD. The Erlang NIFs, of course, have those gotchas that, I mentioned earlier, and plus some other ones that you need to be aware of. Yes?
I just jump in here. We got a question here. Like, can you speak a little to the architecture you have on running this on?
Are we talking about the actual hardware or?
Good question. I don't know. It says architecture.
Okay. I see. Yeah. So at least, I'll talk about how we deploy this in production these days. So we're using a hosting provider called render.com for Doctave, and the way this gets deployed in CI/CD is that we have it's everything's put into Docker. So we have when we do a production build, We'll have a builder image that pulls the Elixir and the Rust tool chains in, does a build, creates what's called an Elixir release or a mix release, which is essentially a self-contained package that has the Erlang runtime, and the Elixir runtime, and also whatever your own code is. And so you don't actually have to have any. You basically don't have to have any dependencies installed on the system where you deploy this system on, assuming, of course, you're running on the same CPU architecture and so on and so forth. And then, once we have that image, we pull that into. Once we have that package, we pull that into a different Docker image, which is a very lightweight kind of production runtime image, where you just dump that mix release, and that will contain the natively compiled Rust code as well. So it all gets put into Docker manages this all for me, and then finally at the end of the day we publish a Docker image to production.
Thanks. Please go on.
If I misunderstood architecture here, do let me know. So of course, so where was I? Yeah. So you also want to kind of be wary of the strengths and weaknesses of your language. Rust. I'm a big fan of Rust as a language. I would never want to write a web application for it unless it was experimental or performance was absolutely critical with it. Elixir and Phoenix allows us to be way more productive. But in this particular case, Elixir just wasn't fast enough for us to actually write the simple code, and Rust let us write the simple code. So this is just something to keep in mind. And this code reuse was pretty interesting. Like we of course say don't repeat yourself, and I don't want to kind of start a trend here. I don't necessarily want to kind of be a hashtag thought leader in any sense, but perhaps actually there are other cases where like languages like Rust or Zig or C++ or maybe where it could be used with your other language right now in these performance intensive parts, or in cases where you really want to be as fast as possible. And maybe it actually isn't that hard to integrate these languages together. Crazy example of that, of course, is that you have these with web applications, especially you have this front end, back end logic, a divide. We have a WebAssembly now. Maybe there's actually ways we can share code, written in some kind of lower level language, and then pull them into other environments. I think this requires a bit more work, but I think this particular case was definitely an interesting exercise in that. And I think this is something that I've sort of been talking about as well, and kind of really relying on, I always want to be simplifying my stack as much as possible. This problem could have been solved in Elixir, just using Elixir, but it would have been more complicated. But then again, one of the reasons we use Elixir already is that Elixir simplifies our stack. Elixir, we don't have to pull in, like for example, Redis or Memcached when we have to reach for a caching system, for a pub subsystem, these sorts of things. Elixir already has got our back, and it just removes another dependency that we have to worry about. And I felt like this, again, surprisingly enough, even though using these two different languages together sounded scary, it actually did simplify things in the end. And of course, there's always trade-offs. It's not a free lunch, but in this particular case, the wins absolutely outweigh the drawbacks. And with that, I'm gonna finish up. So. That's all, and thanks for listening.
Thank you very much, Niklas, for your presentation.
Thank you.
You get applause here from the studio. Thanks. I have one question. How come you started Doctave? What was your motive? You needed to document your own code, or?
Yeah, this is a programmer scratching their own itch for sure. Yeah, I had experiences in previous companies, trying to document my work in general. And, I think a lot of engineers have probably found themselves in a new company and going into the wiki, whether it's Confluence or some other system, and just realizing that everything is completely out of date. And, sometimes the information there is actively harmful. And it turns out that actually a lot of companies that, Google and Twitter and Spotify, for example, they've built these sort of docs as code systems for their engineers to use. And they found that engineers will document code more if you actually let them use the tools that they want to use already. So whether they want to use their favorite editor, Markdown is a simple system. They don't want to use a WYSIWYG editor. And I definitely had felt that, pretty strongly myself. And I wanted this tool to exist, so I've made it exist.
Cool. Also cool that you've shown how easy the nifs are in Erlang. Not that complicated.
Yeah, I gotta say, like, if Rustler didn't exist, I would have had to go and dig into the Erlang documentation. I think it would have been a lot more complicated. I really big hats off to the Rustler folks for making a really solid, easy to use package. Yeah.
Yes, again, I'm checking if there's no more questions right now. Then thank you very much, Niklas, for joining us and for your
Thanks for having me.
Yeah, you're welcome.
Thank you.
You're welcome. Yes, and with that, then I'm going to summarize today. We'll be back again with the last meetup of the year in the beginning of December. The plan is to have a mixed meetup, meaning we'll have some live people in the location in central Stockholm, and as always, we'll stream to everyone else that's not able to join or don't want to join or want to view it online instead. And as always, if you want to present at the meetup, please reach out to me or anyone else of the organizers. We are accepting anyone coming and presenting. You can be the star, you can be the first time presentation. Please come and present. And if you want to sponsor a meetup, just reach out to me. And as always, feel free to contact me on LinkedIn, Twitter, social media, or email, wherever you find the easiest way to contact me. Please just do it. With that said, thanks for joining tonight, and hope to see you all back in December for the last meetup. Bye.